for the stuff that's inside the push.
Yeah.
So this here, I need to take that out.
Yeah.
And call it something else.
Yeah.
Okay. I mean, I guess I'm gonna. Would I just put it down here for right now?
Well, if you're gonna use it in the push, it needs to come before that. But yes, you can always switch the lines later.
Okay. Oh my freaking goodness. Okay. Okay, I'm just gonna call it stuff for right now.
Perfect.
Just, stuff equals this stuff. Hold on. Okay. Wait, okay, but I don't want charge to be a vector anymore. Right?
That's right.
So,
but
I don't want this to be a thing. Like, I don't want it to be a vec new.
True.
I just want it to be something.
Okay.
So would charge just be this, or would, and then charge dot push would be, would I push it onto the atom, or?
Yeah. So this, yes, this exactly. So this is what I was getting at with pulling out the charge dot push, x dot push, y dot push, because instead of pushing these values, instead of pushing everything, you're going to pack these into an atom struct and push that onto a vec of atoms.
Okay.
So that's why I was thinking about doing it incrementally. If you wanted to leave the code as close to what it was, you would just pull out all these pushes, and then you would have all the variables. And then at the end, you could delete all the pushes and then do something different with the values. Okay. But yeah, I mean, we don't have to do it incrementally. I thought it might help, but it might not also.
Well, okay. So with what I just said,
yeah,
I don't want a vector. I just want the thing. So
yes,
would I don't know. Do I need to leave let mute charge equal something up here, nope, or would I put it down here? That's what stuff is in this case.
Yeah, that is what stuff is. Yes.
Okay. So
yeah, and you are only going to use the variables on each line of the loop. So you can just define them in the loop.
Okay. So I can
so you can actually get rid of all 4 of those.
Okay, cool.
Does that make sense?
Yeah.
Okay,
perfect. So I guess then I would need to do all of this, but for each of these.
Yep.
Okay, well, I can just do this, right? I can just do... Oh, man, I can feel your... I can feel the... what kind of cringe Vim... tinkering is he about to do? I can feel it in my bones. Because I was just gonna do this and just 1, 2, 3, and then I don't know.
Are you pasting it? Yeah, for some reason Jitsy's really slow today.
Actually, I didn't want to do that. I just wanted to do this, and then X, and then Y and Z, RY, and then RZ, and then each of these are gonna be 1, 2, 3. Okay, so then instead of all this quap, I just want to do this, shift 4, but I just want to get rid of this.
Now remember your, oh wow, what are you doing?
What do you mean?
No, sorry, don't let me interrupt.
Oh, okay.
I think you might have forgotten to change something on the parse lines, but we'll see.
Well, no, because these are, yeah, right, because these are not, well, wait, hold on. Yeah, right, because the charge is a U size, but these are all F64.
Yep. Yeah, that's all I was talking about.
Yeah.
Yeah, I really don't know about these inlay hands.
Yeah, they kind of suck, like, not gonna lie.
I kind of like them when they just sit there.
Yeah.
But when they have to move around like that, it's kind of jarring.
Yeah. Okay. So I've done these things.
Yeah, that looks good.
Right, but now I gotta remember what I was doing.
Yeah.
I
So
want
this is one of the nice things about doing it in reverse,
to.
right? Where you write the thing before it exists, and then you fill in the gaps.
Yeah, right. So
But yes,
I want
yes,
to
just remember.
push these onto a vector of atoms, or I want to. Okay. Is that okay? So I need to. Do I need to create the new vector, or is that what that is down here, or I need to
Yeah,
put
we just
that
did
here?
that to satisfy the compiler. What we actually want down there is just atoms, but then you have to define atoms somewhere else.
Right. Yeah. So I would say like let mute. Would I say atoms here?
So again, this is a scoping thing. Where do you want to use atoms?
Where do I want to use atoms?
Yeah.
Well, I want to use it down here when I return it.
Right, outside of the loop.
Oh, so I need to put it before the if.
You want to use it outside the loop.
Oh, the whole for loop. Okay.
Yeah.
So let mute atoms. And this is an equals, and then this was the vec new, right? This is vec.
Yes.
New, not new, new.
You're spending too much time around those cats.
I know. Right.
Okay, looking good.
Looking good so far, kid. So now I want to push this onto that vector. Or, wait, hold on. All right. I think my brain is a little stuck right here. I'm trying to think about it though before I. So we have the new vector of atoms, and we have the pieces that go into that vector, and I want to push each of them to the vector.
No.
Perfect. Okay.
Okay. So remember, what type is atoms going to be?
Atoms is going to be a vector of the struct atom.
Okay. So what you're gonna want to
push
onto
I need to push. Okay, wait. So that means I need to put charge X, Y, and Z onto atom.
Yes, you need to construct an atom.
Right. That's right. I need to construct an atom
and push that.
I need to construct an atom.
So
I need to do that.
You can actually delete your push lines.
Okay.
Because those variables as vectors don't exist anymore. You deleted the vectors, remember?
Yes. I want to make do I want to define the struct outside of the for loop as well?
No, because remember each what are you looping over?
I'm looping over charge X, Y, and Z, right? No, I'm sorry. I'm looping over the lines in the file.
And how many atoms are there on each line of the file?
There's only one atom.
Right?
On each line of the
file. So where should you construct the atom?
Oh, in the for loop.
Yep.
But above this, right? Or in this if statement? I would assume it would be outside
where do you have all of the values that you're going to put in the atom?
In the if statement.
Right.
So I would put the atom.
So that's the only place you can construct the atom.
Okay. Okay.
Does that make sense?
I think so. So to construct the struct atom, I do that, right?
Yep.
And then one of these.
Yep. And it's helping you out down at the bottom. It tells you what the fields are.
Yep. So we've got charge.
Yep.
That's. I don't need to do like dot push or anything, or do I do need to do dot? No.
Nope. You're gonna push eventually, but that's for vectors. So pushing is how you put something into a vector.
So
but you need to have something to put into the vector first.
So is it literally just like this?
Yep.
Oh my fucking Lord. Okay. Oh my goodness, dude.
Okay.
Okay, so now we
you
have
to decide. Yeah.
no. Now we have an atom, and so now I need to put the atom in the molecule, or the atoms in the molecule, or what?
Yeah. So now, all right. Now you have an atom.
I have an singular atom.
An atom, and you have a vector called atoms.
No,
Now,
okay. Now I need to do. Now I would need to do. Now I would need to do like atoms dot push or something, or
yep.
Yeah. Is it's atoms dot push, or would it be atom dot push because I'm pushing it onto something else?
So okay, we'll get more into this. I think now that we have structs, we can actually talk about methods, which are how you define functions on structs. But the dot always comes after a variable, basically. So atoms is your vector. You say dot push to call the push method on vector.
Okay.
And then inside of the parens for push, you tell it what to push onto the vector.
Okay, that makes so that okay. So I want to push atom.
Yes.
Okay.
But you want to push an instance of atom. Like you want to push an atom. You don't want to push the type name atom, which is what you wrote there.
Okay.
So actually on the previous line where you constructed your atom,
yeah,
you're not actually doing anything with it. You're just kind of constructing it in the middle of nowhere and abandoning it there.
Okay.
So if you want to hold on to it, you might have to assign it a name.
Okay. I mean,
does that make sense?
Like that?
Yeah, except how do you bind a new variable?
Let you.
Yep. Yep. Perfect.
Okay. What's going on in your brain over there?
My brain?
Yeah.
Oh, I'm just watching you.
Oh, okay.
I'm staring at the code because Jitsi like cuts out. It cuts in and out, and I can't tell actually when you're moving the cursor or not.
Okay. Well, now I don't need this, right? I don't need vec.
Right, because if you remember the issue from earlier, it says that name atoms is not in scope. Yeah. Now atoms is in scope. So if you just delete the colon, you'll be good.
Okay. Okay. Perfect. Probably save that.
Okay. Yeah, looking good.
Oh, perfect. Oh yeah, that's from down there.
Yeah.
Okay. Oh man. More refactoring.
Right. How does this feel?
That feels like a lot that I just learned. Like my brain feels overloaded right now, not gonna lie.
Okay.
Oh man. All right.
Yeah, I think in hindsight we should have refactored a little bit more just inside of the loop before we did the structs.
Okay.
Because what I was trying to get you to do was pull these definitions out, the charge X, Y, and Z. I was trying to get you to define these as variables and then push them onto the individual vectors.
Okay.
So I was trying to do, don't actually change the logic or don't change anything about the program, just extract some variables is what I was trying to do.
Okay.
Because then it would have said, and then we probably would have renamed your vectors before were charge X, Y, and Z, right?
Yeah.
So I probably would have suggested renaming them to charges, X's, Y's, Z's.
Yeah.
And then once you made this change here, where you had variable charge X, Y, and Z, it would have read like charges dot push charge, X's dot push X, Y's dot push Y, Z's dot push Z.
Okay.
So you have some collection of Z's, you're putting a new one in. and then going together with the struct thing, instead of pushing them individually into separate vectors, you're just packing them together into a single atom.
Yes.
And then doing one push of the whole atom.
Okay.
And then the other thing that we've done is, because we introduced two structs, there's like this extra layer of indirection.
Yeah.
So probably the best thing to do would have been, instead of returning a molecule that holds a vec of atom, we could have just returned a vec of atom initially.
Mm-hmm.
And then we could wrap it in molecule later if we really wanted to.
Yeah.
Does any of that help or make sense?
I mean, that makes sense.
But yes, so basically what we did, we mixed the refactoring of giving everything we're pushing a name, and then we also introduced the topic of structs.
Yeah.
Which, I mean, how do you feel about structs in general? It's
No, structs are structs are good. I like the idea. I like the idea of structs. I think the idea of structs is good because it lets me, define that type.
Yeah.
That will hopefully be easier to loop over when we get to the step of actually looping over things. I think that was good. Obviously, it's just the learning of how to put the structs together and how to do all of this kind of stuff is still, it's all very fresh, so.
Yeah, I got you. Does it feel kind of intuitive, like when you build an atom like that down there, right? You just write, it looks a lot like the definition, right?
Yeah, it does. Yeah. I mean, it does. I mean, it does feel intuitive, but I mean, hindsight is, intuition afterwards is always 2020, I guess. So like, sure, it makes sense now that you create a vector of atoms, and then you break up each of these individual pieces into their own thing, and then you construct an atom, like this, and then you push your atom onto your atoms, and then you make a molecule of atoms like that. I mean, that makes sense now. So
okay, that's good. I mean, of course, the point is that you can do this in the future. It's okay for it to be intuitive after the fact.
Okay, good. Because in the moment, no, it's not intuitive. In the moment, my brain, of course not. In the moment, my brain is screaming. It was like, man, I don't get it.
Okay, but does it make sense now?
It does make sense now. Yeah.
If you wanted to make another atom in the future, would you feel better about doing that?
Yeah, if I needed to make another atom in the future, I think I'd be able to. I'd be able to pull up some resources and figure it out.
Okay, nice.
Yeah.
Now, I guess one other question. Do you like having something called a molecule, or would you rather just have a vec of atoms? Because molecule's not doing a lot of work right now. So if you'd feel better getting rid of that one layer of indirection, I think that would be totally reasonable.
I mean, I think I would need to utilize it first.
Okay.
In order to really understand if I like the layer of indirection.
Okay. I just didn't know if that was bothering you. Like, if you'd feel better just seeing vec atom out on its own, then we could do that right now. But
it's not giving me a reason to bother me yet. So, it's not giving me a reason to make me upset with it yet. So I guess it can stick around for a little while longer.
All right.
Before we really go at it.
All right, let's tackle these last couple compiler errors and just at least get your code running again.
Okay. All right, so let molecule. I don't want all that.
Yeah, so if you don't want to destructure it at all, you can just give it a name. Like, you could just call it mol. Mole or whatever.
No, let mole.
Let mole.
Oh, that's so cool.
And another convention, variables are usually lowercase. So the types are uppercase, the variables are lowercase. Snake case is actually what's cool.
Snake case. Oh, look at that. So now we can't even use that, right?
Yeah, but what you could do is debug the whole molecule.
Right. So I would just debug mole.
moi.
Moi.
Now, this also is not going to work, but we can fix it very easily.
Okay, well, I'll let it complain.
I just want you to see what the error says.
All right, so it says molecule cannot be formatted using... Okay. Help. The trait debug is not implemented for molecule. Add derive debug to molecule or manually impl debug for molecule. This error originates in the macro. Okay. So the trait debug is not implemented for molecule. So how do I implement this trait for molecule?
C